Have you ever wondered how hard it would be to program for a advanced robot such as a spot robot from Boston Dynamics? Well, say no more. It's pretty easy actually. Let me show you. Here we have a small program I wrote in Python to let Twitch chat control our spot robot. Our spot robot is listening to the commands provided by Twitch chat, and the spot robot is also sending its visuals on the onboard cameras to the Twitch stream. And we also provide the statistics like the battery life, the last movement commands, and how many players are currently playing in stream to the Twitch stream via OBS. And how do we do that? Well, we need 3 big blocks of code, which you can see here. We have a Twitch bot, we have a message server, it's just a normal web server, and we have a spot handler which handles the connection to the spot. And we have a basic class. So let's take a quick peek at the Twitch Plays class. Upon its initialization, we just load the configuration. Here we load the configuration provided via a YAML file, which you can find here. It has a couple of things in it. It has a host, a name, and those are used to connect with the spot. We have a GUID and a secret, those are used to authenticate with the spot, and we have a Twitch token, which is used for for the Twitch bot, of course. Okay, let's take a look at the activate server. These 3 functions, the activate server, activate bot, and activate spot, are triggered when we start the program. Okay, so first things first. Activate server. Okay, this is the web server. Why do we need a web server? Well, we need to provide some strings to OBS. And how do we do that? Well, in OBS we can open a web page, and this web page is provided by this server. We have a movement callback function. Why? Well, since I want to be able to pause and resume the spot in case something happens, I'll trigger those commands via the web interface, so nobody else can send commands, or spot won't listen to those commands. And you have a stat callback. Why is that? So when we trigger a page, so for example, if we navigate to the local host with the query parameters stat is battery, for example, well, then we get the battery functions. So a JavaScript will keep running on that page and will trigger this callback every so often. Okay, let's take a quick look at it. Server start. Okay, we initialize the server. We have some fancy logging here. We make the callback functions available in the class, and then we start the server. It's just a normal HTTP server, not an HTTPS, and we provide 2 callback functions to it. And here is the handler, those movement callback functions, and the movement and stat callback functions, and those are being triggered here. So if you have a move, if the move is being triggered, we do a callback to that. And if the stats are being triggered, we no, if the battery is being triggered, my apologies. Whoa, it's been a long time. So if the battery or the view count or the last command is being requested, we just provide a JSON string with with the value it requests. Okay, that's that. Next, activate bot. Okay, this is the Twitch bot. Again, we will be needing the config. And what do we need from the config? Well, we need the Twitch token. Okay, let's open the Twitch bot class. We get a username. It was, what was it again? Monster Technologies. Monster Technologies. We have no client ID. We provide the token. The provided token is the one in the YAML file. The channel is also Monster Technologies, and this is the callback function, which will need to trigger movements via the Twitch bot. This is okay. How do we create the bot? Well, it's pretty straightforward, since Twitch chat is just an IRC server and channel. So we just connect to the Twitch IRC server with our credentials, with our token, and when we are connected to the server, we just join the channel. See, join channel. We also request some permissions, and we'll be running the chat analyzer. This is a function that keeps checking every second, or it depends on what we define. But now it's configured as to run every second, and every second we will check which command has the most votes. This is what this chat analyzer does. Okay, next. Oh yeah, the get chat count, but this is needed for OBS, so we see how many people are currently playing. And then we have the on-pub message. What does this do? Every time there is a new message, this function gets triggered in a new message in the channel. This function gets triggered, and what do? We check if the first value, the first character, is a exclamation mark. If so, we remove everything that comes after the first space, and we'll be using this as our command. Then we go to the do command function, where we provide the command. Here we have a list of all the allowed commands. Let's take a quick look. Here you see movement sit stand for blah 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 blah. If it's one of those, where is it? If it's one of those commands, we'll send it to the chat buffer. There is another command, a help command, that I added later. If this is getting triggered, we just make a list of everything is in here, and we'll show it to the user. But if the command is a valid command, and if it's in this, if it is part of this list, we'll put it in the chat buffer based on the nickname of the user. This chat buffer is a dictionary, so every time any user provides any valid command, it gets put in, for example, Monster Technologies used move. Should I use another command in this 1 second or 2 seconds or 3 seconds, whatever we defined, it will override the previous command. So every user gets only one command, and the last command will always be used. The last valid command will always be used. Okay. Then we have the chat analyzers that keep running every second, or whatever we specify here. And we make a copy of the chat buffer. Then we'll clean the chat buffer, and we'll update the chat count to see how many users provided the command in this cycle. We create a new dictionary where we keep track of how many times a command has been triggered, and here for every and here we run through every user that used a command, and we just update those values. Then we sort those values, and we just pick the top value from it. We log which command won, that's just for us, and we trigger the movement callback with the top result. Next, I'll run through the movement and callback stats later. Next, we have the activate spot. Here we also need a configuration, and we provide this configuration to the Spot class. We just create, we just make some logging, we're creating a new robot instance, blah, 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 blah. We provide the initial values for the stuff we need. And then we connect. We also provide a callback function. This is to, this will run once the connection has been made. So we do a connect. We provide the callback function and we put a retry on true. This will just keep retrying the authentication in case we fail. We couldn't connect this if the Spot is still booting or whatever. It will keep trying. Where's my cursor? Okay. So we'll create a standard SDK. This is provided by Boston Dynamics. So Boston Dynamics wrote a Python client that's available as a module, and this will help tremendously in the initial learning phase, or even later phase. I mean, you can keep using this client. It has all the functionality. It keeps getting updated. I tried writing a client in C#. It's pretty doable, just a lot of work, and the only thing you require to communicate with the Spot is gRPC. If you have a language that supports gRPC or a gRCP client / server is available for it, you can use that language. I mean, you can use C#, C++, Python, even JavaScript, maybe PHP, I'm not sure, I think so. Yeah. It doesn't matter what language you use. If there is a gRPC framework available, you're good to go. But this client already has everything configured for us, so we'll be using this. So we just use the create standard SDK, and we'll use this function to create a robot object for us, and we provide it with a host name. This robot function object will be used to authenticate via payload. We can use multiple authentications. We can use the payload credentials, or we can use the username slash password authentication method. But since I already configured this payload for other purposes, I'll just steal its GUID and secret and pretend I'm that payload. Very important, the start time synchronization. Why is this so important? Well, when we have a move forward or backward or whatever command, when we use a velocity, we need to provide how long we want to run that command for, and we don't specify it by using a duration, but we specify it by using a timestamp. So if we want to run this command for like 3 seconds, so for example move 3 seconds forward at this speed, we'll provide the velocity, speed, and at what timestamp it should end. So it's very important to have the clock on your system you're running the code from and the clock on the Spot being in sync. Otherwise, for example, if the Spot is 1 hour ahead, it will try to run forward for 1 hour and 2 seconds. And then we run the pre-flight functionality function, and this is just initializing all the clients you need. How does this work? Well, Spot has multiple services running on its system. For example, it has a Lease service, a power service, a state service, e-stop service, command service, image service. It has a whole lot of services. You can even write your own service, but in order to communicate with that service, you'll need a client. So Boston Dynamics provided a way to communicate with those services by providing us with clients. They wrote those clients. You can write your own clients, but we'll be using those clients. And what are those clients? Lease clients is only one controller. Well, not one controller. Only one system can control the Spot. If it's, it doesn't matter if it's via your cell phone, smartphone, or via this controller, or via a program. It doesn't matter. Only one system can control the spot more precise, can engage with the motors. So this is one level of security or fail-safe, is that the motors are not engaged unless there is a lease on it. So a person saying, I'm in control of the spot and I know what I need to do. Next, you have a power client. Even though the robot is powered on, it doesn't mean there is power to the motors. So that's where the power client is for. But in order to turn on the power on the motors, we need a lease. Next, we have a state client. Is just to request the state of the robot. So we'll be using this to acquire the battery state. We have an e-stop client, and what it does is actually you can say it as an emergency stop client, and this emergency stop is required in order to turn on the motors. You also need to keep this client alive. What does this mean? You need to ping the robot every so often, saying, okay, dude, I'm still here. I can still send an emergency stop if needed. If this is not done, if there is no e-stop client, the motors will turn on, and if the e-stop client fails to ping the robot in the allotted time, the motors will also shut down, it being safely or just fall flat on the floor. Next, you have a command client. We'll be using this to send spot commands like sit, stand, move, etc. And then the image client, and we'll be using this to request imagery from the onboard cameras, especially the two front-facing cameras. Okay, then once these clients are configured, we also configure a movement helper and an image helper, and this movement helper will just an easier way for us to send movement commands, and this image helper is just an easier way for the callback function to start the image stream. Okay, get battery level. Here we see we just use a state client, we request the robot state, and we request the battery states, and we'll pick the, that's actually an array. I don't know why, we only have one battery available for the spot, but whatever. And we request the charge percentage. Enable movement. Okay, let's first return to the callback function, and here we see, oh, okay. Everything we just said happens during the connection phase. So we did a pre-flight here, and if there's a callback function, we just run it. This callback function will start the image stream. So we'll be using this CV2 will provide us with the images, and we'll just capture those images with OBS to send it to the Twitch stream. And then we enable movement. Why is this a different function than the pre-flight or whatever? Because here we need to have we need to define the lease, we need to define the e-stop, the endpoint, the e-stop endpoint, and we need to turn the power onto the motors. So how do we do this? Well, we just use the lease client to take a lease. You can acquire a lease if you are polite. So if there is a lease, if there is no lease available, acquire will just throw an error and saying yeah, there is no lease available. But if we take a lease, we'll just forcibly taking it from somebody else who is controlling the robot at the moment. And we need to keep this alive. So every so often we need to ping the robot from, okay, we're still owner of the lease, don't give it away or don't make it available. Next we provide the emergency stop. Okay, we are the emergency stop for simple setup, blah blah blah. We also need to keep this alive. We just run the e-stop keep alive function, also provided by Boston Dynamics. Thank you very much. And then we'll try to turn on the motors. it happens to fail because there's no battery in it, so there are multiple things required. The hardware lock, which means you have to press a toggle on the spot robot manually to make the to state, okay, motors can turn on, and there should be a battery in it. That button doesn't do anything with the battery. Those are the two requirements. And during testing, I tend to forget to put in a battery since I'm always using the onshore power. Okay, that's for enable movement. Okay, I also made something for disable movement, but we don't really use it. But yeah, just in case I need it. It's just the inverse of enable movements, obviously. And then we have the image viewer. This image viewer is right here. That's the image helper. And the image helper is where is it? Where do I define the image helper? Okay, yeah, right here in pre-flight. The image helper, here we instantiate it. We provide it with the image client. Same for the movement helper. We provide it with the command client. Image client, make it available for this class. By default, we have those two sources, the front right fisheye image and the front left fisheye image. And we have a function stream images with a delay by default of 500 milliseconds. And we'll just use CV2 to, we'll use the image client to get the image from the sources. And for each image, we'll stitch them together. And use CV2 to show the image. And then, last but not least, the movement helper. It's actually pretty basic. We only need one command actually. All the rest is some fancy stuff to make it more easy for us to use this. But we have the command client and we send a robot command to it. And a duration, I mean an end time. And all the rest is logging. We just log which command we sent and we have some potential error loggings. We also have an execute velocity instead of execute command, but this just triggers the execute command with a synchro velocity command builder. And we need this for the forward, backward, left, since these commands are all velocity based. So sit and stand are not velocity based, it's just a trigger for sit and stand, and we can just use the robot command builder synchro sit command or the synchro stand command. And that's just what we sent here to via the robot command. But when there's velocity, you need to provide a velocity X, velocity Y, and a velocity rotation, and a duration being a timestamp end time. Instead of typing this every time, we just wrote a small helper function for this. So when we move forward, we set the velocity X on the velocity base speed, velocity backwards negative velocity base speed. For the Y, the same. So if you go left, it's a Y movement. If we move right, it's also a Y movement but negative. And when we rotate, it's a rotation velocity, and this is provided in this function right here. Those are the velocity base speed, the angular, and the duration in milliseconds and seconds. Sorry. And that's that. So let's run through it quickly. So we have a command, a valid command. For example, sit is being triggered. We trigger the callback function with the command sit. We come in the callback movement. We check if there's a spot object available. If it's allowed the movement. So when pause hasn't been triggered, we can get past this. We set the last move command, so we can use it in OBS. And next we just check via a switch statement. I mean, Python doesn't have switch statements, but we made one ourselves. So if it's a sit command, we just use the movement helper sit, stand, forward, backward, blah, 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 blah. And that's it. It's pretty straightforward, I think. And just some other functions we don't really, that don't really have anything specific in them for this spot. Okay, let's do a quick demonstration of this. Okay, I've just turned on the spot. It has booted up completely, and let's now start our solution. On top you can see the logging, and as you can see, we successfully connected bots. We successfully joined our Moon Technologies channel. We create our message server, service running, we authenticated, our time sync is running, we insert the clients, movement helper has been initialized, the image helper has been initialized. We are starting image stream for the two cameras, as you can see on your left side, bottom left. We are acquiring a lease. We are doing a check-in, endpoint has been configured, and we are powering on the motors, and I've heard them turn on. So, join Twitch stat, and I'll type stand, and we'll be seeing it in our logging. 1 minute 1 vote, and it's standing. We do a backward command. There you go. Oh, it's stand. Turn left command. Turn left. Turn right. Sit. And there we have it. Everything is working. So next I'll show you some screen caps from the stream we had with around 15 people. Not many, but yeah, it is what it is.